Hi, we're Team Good Luck. We've created a portfolio to record the analysis, decision making and linking behind the game scenario to supply chain ideas. Furthermore, we'll be analysing the task and potential improvements for the future as well as improvements to the decision making process. First we will cover source, make deliver problem including the score model. Then we will outline the fundamentals of lean supply chain and how we apply this in a game scenario to improve our operations. And lastly, we'll talk about the concept of agile supply chain and how we implemented its principles to adapt to our supply chain.
This is a spreadsheet showing our calculations for total costs and time taken to market across March to June 2019. We chose Factory H and Factory S for make. Our manufacturing totals in March 2019 were $156,000 at $26 per unit, which after using Excel functions to simulate different combinations, for example NNS, Ningbo, Ningbo, Shenzhen, it was by far the cheapest. It took 5 weeks to produce subcomponents A, B and then assemble product X as part of their lead times. For the shipping portion, we chose our shipping location to be in the port of Shenzhen, where this was also responsible for assembly. We chose the company Fast Trucking to deliver product X from the factory in Factory H to the port for international shipping. The total transportation costs are $12,138, with truck delivery of A and B to Shenzhen only costing $31, which was also the cheapest option. The shipping company we have selected to take product X across seas is Coast to Coast Shipping, which delivery time to the US market is 18 days and 28 days to European markets. The total cost for March 2019 is $168,138 and costs $28.02 per unit. In the following months, MACE costs increase to meet the forecasted demands levels of product X, but deliver costs stay constant because there is suitable delivery capacity from truck and ship transportation. Manufacturing costs are thus the only costs that change. As you can see, these have increased. Our supply chain for product X is as follows.
To plan the route that the product will be travelling, we looked at geographic locations of potential factories, ports and also the distance of the roads that would be applicable for delivery routes. The combination of factories H and S, HHS, was chosen for the manufacturing of product X based on their close proximity to each other and low subcomponent costs. Thus, it was cost productive to produce subcomponents A and B in the same factories, H, rather than separate ones, saving on transportation costs. For the delivery portion of the supply chain, both road and sea methods of transportation are required, likewise with make. Fast trucking is preferable to Go Logistics for our supply chain because they provide overnight delivery, which will be more efficient to get product X to the port in time. The shipping company we selected is Coast to Coast Shipping, which was based upon the shorter duration of travel compared to the alternative. These are quicker methods to transport product X from Factory H to the port and then onward to the end consumer in America and in Europe. It is important to choose optimal delivery routes to achieve better efficiency in the supply chain. Using the SCORE model allowed for better logistical delivery planning, bearing effects in mind. It is also important for examination of these costs to determine the best cost and time efficiencies.
When we started playing the game, our supply chain wasn't very efficient due to an inconsistency recognized as an error. We experienced the accumulation of waste due to an uneven volume of work at each station and items accumulating between them. Workstations were interdependent and one station couldn't do the work unless the previous one finished. It led to different types of non-value adding activities recognized under the Japanese concept of MUDA, which led to different types of waste. We produced more than needed or before it is needed to meet customer demand each time. Time was wasted while waiting for the next step in the process and talent couldn't be used effectively as well. Workstations were not logically organized and it caused unnecessary movement of people and materials. Many defects and wastage appeared as well as inventory excess because not all materials prepared were needed.
At the start of the scenario, we had many non-value-adding activities taking place in our supply chain. After removing the non-value-adding processes, we experienced better efficiency. When I was doing the job of the guillotine in the supply chain, I was trying to meet unreasonable requirements as if all the stations were asking for different colour bases and tops at the same time. The overburdening demand from all of the stages in the chain produced a negative effect on the process. This is identifiable as mirroring. Next, we applied Kanban, pull production, and produce only what is required, instead of making lots of inventory just in case. It resulted in reducing our waste from minimising overproduction, but did not allow for us to meet customer demand every single time. When the game was stopped, we had an opportunity to make our supply chain leaner by applying changes necessary after the analysis of our operations was made. We decided to purchase a new heated jig for the assembly stage 2 and invest in staff training, which resulted in a total cost of £400. This helped us to minimise the probability of a bottleneck in our machine and became more efficient and more reliable. We have also decided to repair the existing heat treatment bar for £300 to improve the quality and make the processing time shorter. To avoid unnecessary movement of product and people, each station was in chronological order.
During the game, collecting all wastage materials to keep the space clean and tidy proved to be an advantage. Following the idea of Kaizen, we believe that these small changes will lead to major improvements. After changes were applied, we were able to deliver the widgets on time and match supply with customer demand, known as pull control. As customer satisfaction is our priority, we believe that after changes implemented, our supply chain became leaner and therefore we are able to deliver high-quality product on time and within minimal wastage.
Reflecting on the changes that were made in week 5, with the addition of the new heated jig, the training of staff for this new implementation, and the repair of the heat treatment bar, we had established a more lean supply chain. We were able to see this through a significant reduction in wastage as we carried on the game. In week 6, we continued the game scenario. This week is about becoming more agile. Agility is a supply chain-wide capability that aligns organisational structures, information systems, logistic processes, and importantly, mindsets. The focus is on the end consumer and ability to react to changes in volume and variety. An agile supply chain can be created through the implementation of organisational aspects, such as breaking through functional silos to create improvement, making process teams, and maximising autonomy, but also through change in mindset, forecasting, manufacturing, and supply chain partnerships. Following the email, we decided to enter a new market for simplified widgets with a projected price of £50 to £80. We decided this because with the increasing competition and decreasing demand of the old product, there is now demand for consumers in a new product. Being market sensitive is a key part of creating an agile supply chain. This new, simplified product means that we are able to remove the heated jig and stages 2 and 3 from the supply chain, reducing complexity.
This change allowed us to adapt the supply chain to become more agile. Operationally, we synchronized activities through shared information and worked smarter instead of harder by removing 2 stages. Through this, we have also reduced complexity. From Shang and Sharaifi's taxology, we are thriving in anticipated change. We avoided time and cost penalties of standalone processes by integrating and synchronizing parts of the supply chain. However, being agile needs to go hand in hand with stability. In agile supply chains, both stable and agile supply partnerships are required. To determine the criteria for a suitable change, Cerruti found that the type of strategic supply partnership, where stable being long-term or agile being short-term, is dependent on these characteristics. First, being the component or service, the extent to which it is impacted by the aesthetics. Second, being the degree of turbulence an agile strategy is designed to face. As a result of the new supply chain process and simplified product, we achieved a more responsive, flexible, and therefore agile supply chain.
We started by emphasizing the importance of source, make and deliver from the SCOM module. This included supply and production selection, scheduling, facility and order management, and order delivery process based on costs and time in order to respond to the demand study provided by a logistical analysis. We have implemented a linear approach into a manufacturing supply management game simulation by refining synchronization, behavior, customer focus, and the 8 types of smoother waste elimination. This resulted into changes that have improved mainly manufacturing process by adding higher product quality to a quicker and more effective production process in order to respond to customer needs. Lastly, we focused on the agility of our response, which through logistics help us adapting to a dynamic and competitive market evolving us. This time, we adapted our product to the demand changes and risk taken by entering a new market. At the same time, we were able to simplify our production process and be more cost efficient. Overall, the 3 topics demonstrated the importance of international supply management from supply to customer, including constraint probability and resolution through the application of the learned frameworks.